Our planet is a world of constant motion. Every moment it is in a state of perpetual change, influenced by forces both near and far. We spin through the vastness of space, a tiny blue dot in an immense universe. We orbit our star, the Sun, completing a journey around it every 365 days. And on our surface we witness the ceaseless ebb and flow of the tides, a dance of water that never stops. Tides are the rhythmic rise and fall of ocean levels, a natural phenomenon that has fascinated humans for millennia. They are a fundamental force of nature. Tides have shaped coastlines, carving out cliffs and creating unique landscapes. They have influenced marine life for millennia, providing habitats and influencing the behavior of countless species. For centuries, people have observed the tides, noting their regularity and trying to understand their cause. They noticed patterns in the rising and falling waters, patterns that seemed to follow a mysterious schedule. Ancient civilizations often attributed these patterns to mythical creatures, gods, and supernatural forces. They told stories of sea gods and monsters controlling the oceans, weaving tales that blended observation with imagination. But today we understand the true force behind this natural wonder. Science has unveiled the secrets of the tides. It is the invisible hand of gravity, exerted by the moon and the sun, that orchestrates this magnificent phenomenon. Tides are most easily observed along coastlines, where the difference between high and low tide is most dramatic. Here, the difference between high and low tide is most apparent, revealing the power of the ocean's pull. Imagine walking along a beach at low tide, the sand stretching out before you, the ocean seemingly far away. You can see tide pools teeming with life, small ecosystems that thrive in the intertidal zone. The ocean seems distant. Hours later the water rushes back in, reclaiming the land it had temporarily surrendered. The beach shrinks, and the sea reclaims its domain, a reminder of the ocean's relentless power. This constant cycle of advance and retreat is the pulse of our planet, a rhythm that has been beating for billions of years. It is driven by the combined gravitational forces of the moon and the sun, a celestial dance that shapes our world. The moon, Earth's celestial companion, plays a starring role in the drama of the tides. Its presence is a constant reminder of the delicate balance that governs our planet. Although much smaller than the sun, the moon's proximity to Earth gives it a stronger gravitational influence on our oceans. This gravitational pull is what orchestrates the rhythmic rise and fall of sea levels. Gravity is a fundamental force in the universe. It governs the motion of planets, stars, and galaxies, binding them in a cosmic dance. It is the invisible force that draws objects with mass towards each other. Without gravity, the universe as we know it would not exist. The moon's gravity tugs on Earth and everything on it. This gravitational interaction is a key factor in the natural phenomena we observe daily. This includes the water in our oceans. The moon's gravitational pull causes the water to move, creating tides that are essential for marine life and coastal ecosystems. Imagine the Earth and the moon suspended in the vastness of space. Their gravitational interaction is a delicate balance that has been maintained for billions of years. The moon's gravity pulls most strongly on the side of Earth facing it. This pull creates a bulge of water on that side of our planet, a phenomenon we recognize as high tide. This pull creates a bulge of water on that side of our planet. The gravitational force is so strong that it can lift vast amounts of water, creating the high tide we experience along coastlines. This bulge is what we experience as high tide. The rhythmic rise and fall of the tides are a testament to the moon's powerful influence. But the story doesn't end there. The gravitational interplay between the Earth and the moon creates another fascinating phenomenon. On the opposite side of Earth, farthest from the moon, another bulge occurs. This secondary bulge is equally important in the tidal cycle. This bulge is a result of inertia. Inertia is the tendency of an object to resist changes in its state of motion, a fundamental principle in physics. Inertia is the tendency of an object to resist changes in its state of motion. This principle explains why the water on the far side of Earth also forms a bulge. The water on the far side of Earth experiences less gravitational pull from the moon. This reduced pull allows the water to bulge outward, creating a second high tide. As a result, it bulges outward as if trying to break free from the moon's grasp. This interplay of forces is a beautiful example of the laws of physics in action. This creates a second high tide. Together, these two bulges, one on the side facing the moon and one on the opposite side, drive the tidal cycles that shape our coastal landscapes. As the Earth rotates on its axis, different locations on our planet pass through these tidal bulges. This rotation creates the regular cycle of high and low tides that we observe. Most coastlines experience 2 high tides and 2 low tides each day. This is known as a semi-diurnal tidal pattern. The time between high tides is approximately 12 hours and 25 minutes. This is because the moon is also orbiting the Earth. As our planet rotates, the moon has moved slightly in its orbit. This movement means that a point on Earth needs a little extra time to catch up to the moon's gravitational pull and experience the next high tide. The difference in height between high and low tide is known as the tidal range. Tidal range varies depending on several factors. These include the moon's phase, the distance between the Earth and the moon, and the local geography of a particular coastline. While the moon is the primary driver of Earth's tides, the sun also plays a role in this celestial dance. The sun's gravitational pull is weaker than the moon's because it is much farther away from Earth. However, its influence is still noticeable, especially during certain phases of the moon. When the sun, Earth, and moon are aligned, their gravitational forces combine. This alignment happens during the new moon and full moon phases. During these times we experience more extreme tides called spring tides. Spring tides have higher high tides and lower low tides than average. Conversely, when the sun, Earth, and moon form a right angle, the sun's gravity partially counteracts the moon's pull. This occurs during the first and third quarter moon phases. During these times we experience less extreme tides called neap tides. Neap tides have lower high tides and higher low tides than average. Section 5. Tides, shaping life in our world. Tides are more than just a fascinating natural phenomenon. They are a rhythmic dance of the ocean, driven by the gravitational pull of the moon and the sun. They are an integral part of our planet's ecosystem and have significantly influenced human activities. Coastal communities have long depended on the predictable ebb and flow of tides for their livelihoods. Tides play a crucial role in coastal ecosystems. They bring in nutrients and oxygen, which are vital for the survival of many marine species. They create a dynamic environment that supports a diverse range of plant and animal life. The intertidal zone, where the ocean meets the land, is a bustling hub of activity. Intertidal zones, the areas of coastline that are submerged during high tide and exposed during low tide, are particularly rich in biodiversity. These zones are teeming with life, from tiny microorganisms to larger marine animals. These zones are home to a variety of organisms adapted to survive in these constantly changing conditions. Crabs, mussels, sea stars, and sea anemones are just a few examples of the creatures that thrive in these environments. Each species has unique adaptations that allow them to endure the harsh and fluctuating conditions. Tides also influence human activities, particularly fishing and navigation. The rise and fall of the tides determine the best times for fishermen to set out to sea. Fishermen have long relied on their knowledge of tides to predict the best times to catch certain species of fish. This ancient wisdom has been passed down through generations. Tides can also affect the depth of water in harbors and channels, making them critical factors for navigation. Ships and boats must carefully time their movements to avoid running aground. Understanding tidal patterns is essential for safe and efficient maritime transport. Mariners use detailed tidal charts to plan their routes and ensure smooth sailing. Section 6. A world without tides, an unsettling thought. What would happen if the moon suddenly vanished? Our world would be a vastly different place. Without the moon's gravitational pull, tides as we know them would cease to exist. The oceans would redistribute themselves, resulting in a permanent high tide along the equator and a permanent low tide at the poles. This dramatic shift in ocean currents and sea levels would have catastrophic consequences for coastal communities and marine ecosystems. The delicate balance of intertidal zones would be disrupted, leading to the loss of countless species. Coastal cities would be at risk of flooding, and the global climate would be significantly altered. The moon's influence on Earth extends beyond tides. It stabilizes our planet's axial tilt, which is responsible for the seasons. Without the moon, Earth's axial tilt would become unstable, leading to extreme and unpredictable climate changes. Section 7. Tidal tales, facts and folklore from around the world. Tides have captivated human imagination for centuries, inspiring a rich tapestry of myths, legends, and intriguing facts. In ancient China, tides were believed to be the breath of a dragon living in the sea. The Inuit people of the Arctic attributed tides to the rhythmic beating of a giant sea monster's heart. One fascinating tidal phenomenon occurs in the Bay of Fundy in Canada. This bay experiences the highest tidal range in the world, with a difference of up to 53 feet between high and low tide. This dramatic change in water level creates a powerful tidal bore, a wave that travels upstream against the current of a river. Another intriguing fact is that tides can generate electricity. Tidal power plants harness the energy of rising and falling tides to generate renewable energy. These plants offer a sustainable alternative to fossil fuels and are gaining increasing attention as we seek to combat climate change. Section 8. The Interconnected Cosmos, Our Place in the Universe. The story of tides is a reminder of the interconnectedness of our universe. The moon, a seemingly distant celestial body, exerts a profound influence on our planet, shaping its oceans, coastlines, and even the rhythm of life itself. Understanding the science behind tides allows us to appreciate the delicate balance of forces that make life on Earth possible. As we gaze up at the night sky and witness the ebb and flow of the tides, let us remember that we are part of a vast and awe-inspiring cosmos. Every celestial body, from the smallest asteroid to the largest star, plays a role in the grand symphony of the universe. And we, here on this pale blue dot, are fortunate to witness the wonders of this cosmic dance.